All right, good afternoon, everyone. My name is Samantha, and on behalf of Carasoft, I would like to welcome you to our primer webinar, The 5 Levels of AI Tradecraft for Intelligence Analysts. And now I'd like to introduce our speaker for today's presentation, John Bohannon. He is the VP of Data Science at Primer AI. And with that, I'll turn it over to John. The floor is yours.
Thanks very much. Let me just get my presentation up here. All right, how's that coming through?
Looks good.
All right, good morning. I'm going to be talking about AI tradecraft. And what I mean by that is tradecraft in the sense of an intelligence analyst. So in the government, intelligence analysts find their way throughout both the military, the intelligence community, and also other parts of the government. In fact, that role of being an intelligence analyst finds a place in large corporations and other kinds of large organizations. So, what I'm focusing on is how AI is bringing new tools, and those tools have their own tradecraft. There are best practices, there are pitfalls to using it badly, and there are cognitive biases that you have to watch out for. So, I'm going to walk you through 5 levels of AI tradecraft as I see it. And these have really emerged over the past few years, which is very recent in terms of technology, as we've here at Primer worked with our intelligence community customers in particular. So I'm going to use an example of the kinds of tasks that an intelligence analyst cares about to motivate this talk. But I think no matter where you're coming from, you're going to see applications of this tradecraft probably in your own work. So, just to give you a heads up on the menu, we're going to be talking about search, which is the most familiar, going through to structure, retrieval augmented generation or RAG, chat, and then finally agents, which you've probably all heard about. This has really become the year of agents, and we'll get into that. So let's start with search. Here's a typical task that might land on your desk as an intelligence analyst. You need to provide a brief on Ukraine's diplomatic relations with NATO member states. There's probably a lot more caveats and details to that task, but that's the essence. So you need to get up to speed fast. So this is today's reality for intelligence analysts. They all rely on a search technology called Boolean search, and it's vocabulary based. So in a nutshell, the way it works is the system takes the user's query, which you're seeing an example of there, and it tries to find documents that match those conditions. So on the right side, you're seeing a real Boolean query that tries to capture documents about Ukraine's diplomatic relations with NATO member states. So why is it so long and complicated? Because it's just looking for words, right? So if you just look for the word Ukraine, diplomatic and relations, you're only going to find documents that specifically mention those exact words, letter for letter, and you're going to be missing a ton. So what you have to do is cast a wider net. And crafting that Boolean net, that query, is so tricky, involves so much tradecraft that these Boolean queries, I kid you not, are handed down like family jewels from analyst to analyst. So, if even if you're a seasoned analyst and you join a new team or you get tasked with something outside of your comfort zone, your first thing you're going to do is look to see if anyone has a good query to capture the kind of docs you need, because making this thing is not easy. So this is what AI is bringing to us. And I'm not talking yet about large language models. This predates that, but it's very powerful, and it is already transforming that most fundamental starting point of an intelligence analyst day, which is searching for what to read. So the kind of magical thing about semantic search is you can actually just say what you want. So just to remind you, this Boolean query can really be expressed as that sentence, that question, which is pretty life-changing. I mean, if you have to spend an hour just, crafting the perfect Boolean query just to get started finding things, imagine how your life changes when you can get semantic search by just asking questions directly. Okay, how does it work? So here's the technological magic. So that query in red, that actual string of letters, gets sent to a language model. So semantic search doesn't work without this magic technology called a language model. I'm sure you've all heard of large language models. This is really no different. It's just smaller. So what the language model does is it creates what are called vectors or embeddings. They're just taking English language text and turning them into a bunch of numbers. And so you take the user's query, you feed it to the language model. In advance, you've already taken all the documents of your organization or whatever you want to search on. You've chunked them up, turned them into text passages, and each of those gets sent to the language model as well. Stay with me. I know this is complicated looking, but it's actually not that complicated conceptually. All of that, your query and all of those text passages from the docs you want to search, end up getting turned into these vectors that are in this high dimensional space called the semantic space. So somewhere in that space is your query. See the red brick right there inside the semantic space? That is the address, if you will, in a high dimensional space. How many dimensions? Typically about 300 or 700. So, you're probably familiar with 2D space, which is a flat piece of paper, and 3D space, the room around you. This is just a space that happens to have, over 300 dimensions. But conceptually, what I'm showing you here is really how it works. We literally find out where your query is in that semantic space amid all of the document passages that we want to search on. And, it will be closer, your query, to documents that are about NATO, because you're searching for Ukraine's diplomatic relations with NATO member states. It will also be pretty close to docs about Ukraine. But what you really want are the ones that are right around your query, that are docs about Ukraine's diplomatic relations with NATO. That's what you really want. And so what we finally do is we literally draw a circle in high dimensions around the nearest neighborhood docs and grab them. And it's really no more complicated than that. We measure how far they are from your query and rank them accordingly. And so there on the right is what comes out. Search results. It's really not different when you do a Google search and it shows you, the top 20 websites. Under the hood, it's doing similar things. It's just finding things that are similar to your query and hence hopefully relevant and ranking them by how relevant they look and presenting them to you. So that's semantic search. It seems complex, but it's really same old, same old. Find me docs that are similar to what I'm looking for. Okay, so becoming an expert in semantic search is really great because you can just ask questions in natural language, and it does a really surprisingly good job of finding things for you. However, look at these three problems that you might be faced with during your briefing, writing your briefing. So the first is, which NATO state leaders have visited Ukraine recently? Well, that's tricky, right? If there is a single document that someone wrote that right there just lists, the NATO states that the NATO leaders that have visited Ukraine, then you're golden. You just need to find that doc. But that's not the way that the world works. Usually, the information you need is kind of scattered across many docs. And that's actually what makes it hard is when you're trying to find like a number of things, in this case, like which NATO leaders, and it's all not just listed in one doc, how do you find the answer to such a question? The second one is, which summits has Zelensky attended? Same problem. If there is a document where someone wrote down in one place all the summits that Zelensky attended, then you're golden. You're done. You just need to find that doc. But it's probably not the case. There's probably multiple documents describing different summits, and so you need to find all those docs. And the last one is even trickier. How do NATO state leaders feel about Zelensky? So this one's even more challenging because you can you can bet that such questions often don't even have an answer in any doc. Literally, no one has answered the question that you need answered. So, how do you even begin? So, this is the second level of AI tradecraft is to make use of structure. Structure is something that we can create when we ingest documents and we can save them in a database so that you can use them when you query. So sometimes it's called annotations, sometimes it's called enrichments, but it's all the same thing. You're going to take your documents, you're going to apply some algorithms. A lot of them involve models. In fact, a lot of them involve language models, but don't worry about the details. The point is, if you have a search system that can do nothing but find documents based on, the query that you're posing, like find me docs about X, and it's going to go and do semantic search or even Boolean looking for documents that seem to be talking about X, that's usually not enough to get your job done. In fact, it rarely is. So often what you need is to do things like this. So let me just walk you through this. That first task was which NATO state leaders have visited Ukraine recently? Well, it would be really handy if we've already discovered of the probably millions of documents that you're searching on, which of them are actually talking about diplomatic meetings. So, what would be really nice is to have a document classifier that has in advance, before you even knew you needed it, gone through and tagged every document at ingest as soon as it's published into your system with whether or not it is one of these categories. So what I'm showing you here are called dime fill categories. This is a part of intelligence community tradecraft going way back. These are just categories that are known to be essential to your job. It's just very useful to know how to find documents that are about law enforcement or about diplomatic relations. And so this helps you avoid boiling the ocean. If you're looking for every NATO state leader visit in Ukraine, don't look at every single document. You could constrain yourself to diplomatic documents, right? Because that's surely where the information you need lies. The other thing I want to bring your attention to is on the right. So that second question, which summits has Zelensky attended? Well, Zelensky is a person, right? And so another thing that would be really handy is to only look at documents that are talking about the person Zelensky. And there's a very tricky aspect, especially with foreign names, that I'm going to get to in just a sec. But suffice to say, it's very, very handy when you've already found all the person, organization, and location entities mentioned in documents, because then you can search on them, just like good old-fashioned database search. So, for example, um, you know, Zelensky as a person, but also those locations where those summits happened. Those are, also pre-detected if you have named entity recognition up and running. Finally, that last one, how do NATO state leaders feel about Zelensky? So if all you have is search, you're kind of stuck because unless there's a document where someone actually did some analysis of how NATO leaders feel about Zelensky, through some analysis of everything they've said, and wrote it down in a doc, and you can find that doc, you're at a dead end. But what if we had sentiment analysis, for example, already created at ingest and annotated into a database? So I show an example here of real data. So you've got a social media message from President Trump that says, "A dictator without elections. Zelensky better move faster. He's not going to have a country left." Sentiment analysis, particularly a more advanced version called targeted sentiment analysis, will be able to find that sentiment of type negative has been expressed from someone named Trump towards someone named Zelensky. Now imagine doing that at scale for every NATO leader. So you've got everything they've said in the news. So every quote from every NATO leader, everything they've said on social media. You can run targeted sentiment analysis on that and convert it into structured data that you can then pull together, search, aggregate, it's pretty amazing as an intelligence analyst who has to answer the question, how do NATO state leaders feel about Zelensky? If you can get that data just all zapped out of the millions and millions of docs that, where things might be said, down into a data set that has structure. So you can simply do an analysis. Um, here's that promised gotcha. So this is part of the tradecraft. If you're interested in an entity that happens to be a person, and that person's name is not a English name, you're going to have all kinds of challenges. So one is transliteration, which I'm showing you here on the right. The name Zelensky can be expressed in a ton of different ways. And unless you're thinking about that and adding it to your query as all possible alternatives, you're going to miss a lot of documents that might be talking about Zelensky, but that used a different spelling. Another problem, of course, is that people have aliases. And an even harder problem is that some people have very common names, the John Smith problem. And so, how do you tell just because some person's name got mentioned and detected by entity recognition that it's the person that you're interested in? There's two ways to fail. You could be missing a ton of the data because they have aliases or different spelling name versions of their name, or your data could be hopelessly muddied up with people who have the same name but are totally different people. So this bedevils intelligence analysis. And the solution to that is something called named entity linking, which is yet another thing that you can hook up at ingest time and gather as structure into a database as annotations or enrichments. Although with named entity linking, often you have a purpose-built database, often called a knowledge base, that just keeps track of everything known about particular entities. So, suffice to say, structure is really important. And the tradecraft here is knowing that it exists and knowing how to use it. So, if you have a system that has document classification and entity recognition and sentiment analysis and all this stuff, I haven't even talked about relation extraction yet, which is here. um, you can get a lot of power out of your search system. So just really quick, relation extraction there on the left is going to be really handy when you're trying to figure out who are NATO state leaders. That one's a bit of a softball, right? You could just look that up. It's numerable. It's not, like a huge number. You could literally just find out who all the NATO leaders are. But what if the entities you were looking for was a much larger number? Like every current and former NATO leader, or every current and former diplomat from Europe. It can get explosively large. And so another way that structure can help you find these entities is by relation extraction. Here on the left, you've got a pretty traditional example of relation extraction, where a person could be a spouse of another person, a person could be a parent of, a sibling of another person, but also a person could be a leader of an organization, could be employed by an organization, or a member of an organization. So as you can imagine, having the structure of these relations in your database and having it searchable is very powerful. Okay, on to the next level. Now we're getting to large language models. So first of all, I just need to make sure that you understand what the words mean, because it's so easy to get kind of lost in technical terminology. Um, but it's a very straightforward concept. Retrieval augmented generation, RAG, is how you help someone with, again, that traditional problem of finding information. So if the task is, what are Ukraine's diplomatic relations with NATO member states? What you can do is, again, run that with semantic search. Okay, you see the bright red retrieval on the right side? That's the R in RAG. You just do what I showed you in the beginning. You just go and run semantic search to find relevant passages of documents. So now that you've retrieved that stuff, the next thing you do is you take those search results and you stick them into what's called a prompt. Now, if any of you have used ChatGPT, then you're familiar with prompts. It's just a set of instructions or part of a conversation. It's just text at the end of the day that you're passing to a large language model. and the large language model is figuring out what to say next. So in this case, what you would do for a RAG system is, hooked up to search, is you would take that user's query, those search results, and some instructions for what you want it to do, and package them all together into this prompt. It's really a game of Mad Libs. It's not, this is not fancy computer programming, trust me. You're really just like sticking things into a document, and then you pass it to this large language model, and out pops this answer to the query. Now, I want to bring your attention to something really important in that generated answer, which is those citations. See the bracketed 1, 2, 3, 4, 5? Those, if the large language model has done its job correctly, are very faithfully pointing at those search results, 1, 2, 3, 4, 5. Now, the reason that matters is because of a problem called hallucination. So if you don't carefully instruct the model in the instructions that are in that prompt to stick to the retrieve search results and cite them faithfully, it can run off the rails. So that's another part of Tradecraft I'd be happy to get into during the Q&A if you want to dig into it. And there are ways to constrain the model even further to make sure that it doesn't hallucinate. So what's wonderful about RAG is, imagine yourself doing search as you have like mere hours to write up that brief on Ukraine's diplomatic relations with NATO. Yes, you could just use search, just like one query after the other. The problem is all the system is doing for you is presenting you documents to read. So now you're limited by your human eyeballs and your human brain for how fast you can suck up information. And intelligence analysts are the best in the world at this. Ask any intelligence analyst how fast of a reader they are, how good of a skimmer they are, and they'll tell you they're the best. Because, you know, you might have like on order of 1,000 documents you have to at least look at before you decide which, I don't know, 10 documents you're going to really deep dive and read. And that's exhausting. So what RAG provides is a large language model AI buddy reading over your shoulder and sees the same search results that you do when you do a query, but it can actually take a crack at answering your question. And the reason this is powerful is because it's saving you the necessity. You can still do it yourself, but it saves you the necessity of having to scan the top, call it 25 results. These are chunks of text that you have to read to figure out why they're relevant to your query. And by having this kind of rough first draft of an answer, it lets you very quickly, much more efficiently at least, zoom in on the search results that are the most relevant. And it lets you iterate very quickly because you don't have to stop for several minutes to trawl through the search results every time you make a query, which leads us to level 4. And, probably everyone in the room is familiar with ChatGPT. I hope you are. If you're not, you really should be using it. What's so great about chat? In a certain sense, it's trivial. It's really just like a user experience tweak, right? You're still doing search and asking questions. It's just formatted into a more natural flow, a conversation. So rather than just RAG, where you're kind of locked into the cockpit of search and it's just query after query after query with kind of, I call it statelessly. Each time you run a new query, the system isn't paying attention to what queries you ran before. You have to do it from scratch every single time. Putting it into a conversation, a chat conversation format, actually allows you to speak and explore and think more naturally as a human. The way you might kind of chat with a colleague who's sitting next to you, who has access to the same information you do and can talk about it. So I've given an example here. It starts again with this question of what are Ukraine's diplomatic relations with NATO member states? So here, what you see right below that is the results of a search. I've folded it up so it doesn't take up the whole screen. It found 388 documents, and out pops the answer from RAG. So the large language model read the top however many documents from those 388 and generated this answer. And now, rather than having to go back and leave this environment and launch a new search and keep everything in your head, you can just say the next most natural thing, which is which NATO states are most resistant to Ukraine's membership. So that might be the next question on your mind. Now that I know more or less what the relation landscape looks like, now I want to look in on the hotspots. So, who's fighting? And maybe a search gets launched, they find 85 documents, and the model through RAG just says Germany and Hungary are currently the most resistant to Ukraine's NATO membership. You can read documents 1, 2, and 3 for information about that. And that's great. But look at what happens next. This is where I think chat really shines. The analyst is able to then just say, what is Hungary's complaint? And get an answer. So Hungary opposes Ukraine's NATO membership due to concerns that it would harm Hungarian farmers and the national economy. It views Ukraine as a buffer zone, yada, yada, yada. So if you just said, what is Hungary's complaint as a query, right? Forget chat. We're back in like search land. You're not guaranteed to find any good results, right? First of all, what is Hungary's complaint doesn't even mention Ukraine. So any search system would be like totally at a loss. I can't even tell you what rando docs would come back from a search on what is Hungary's complaint. You're certainly far from guaranteed that it's going to have a doc about Hungary's complaints about Ukraine's NATO membership. So, but that's the way a human in a conversational chat setting would ask that question. It's a follow-up question. What is Hungary's complaint? And if you were talking to another human, they have the whole context of this chat, and they totally understand what you mean when you say, what is Hungary's complaint? The system, with the help of an LLM that has all this context, all that state, knows that the query, and I actually wrote it down right below there, is what reason has Hungary given to block Ukraine's membership in NATO? So the LLM is smart enough to use the context to launch the appropriate search and answer the question. So it mostly boils down to convenience, but convenience is powerful because convenience means you're lowering the cost of doing the work of an analyst. It's like lightening your load cognitively. It allows you to like ask questions that you probably would be too exhausted to ask if you had to go back and do the right search every single time, read the documents, make sense of it, keep track of this in your head. Which brings us to the final level, agents. So what is an agent? Well, let's reframe it in the context of the job of an intelligence analyst. You need to generate this brief on foreign relations with NATO member states. It's due today, right? So let me show you the dream state of an agentic. So that's any system involving agents. I don't know if that word is going to stick, but people are using it, so I'll use it. Agentic system. An agentic system would first make a plan. So that plan would be, hey, I'm going to, step one, generate a timeline of recent diplomatic events involving Ukraine. I'm writing this in shorthand. It would probably be more verbose. Step two, for each of those events, I'm going to explore the implications for Ukraine-NATO relations. Step three, I'll summarize and rank each of those things I found. And then finally, step four, I'm going to synthesize it all together and draft the brief in question. So, the way that would actually play out is step one would result in generating a step one plan. So to achieve step one, I would have to do this. For each NATO member state, I'm going to have to launch a search on recent documents for diplomatic developments with Ukraine. I've got to summarize them, organize them into a chronological timeline of key events. Each one of these things is an action. So this is a special word when it comes to agents. And the difference between an agent and any other AI system is that agents can take actions. That's what agency implies. And so each one of these things is an action. Launching a search, generating a summary, creating a timeline. All of those are actions. And they can be farmed out to individual AI agents, or really they're just jobs. At the end of the day, it's not like there are literally separate AI agents doing things. There's really just one AI system, but everything is organized into tasks. And this is like the ideal. All right. And if you've seen any of the marketing material from OpenAI or others on deep research, you've gotten a glimpse at what it can look like to make a plan and generate a document that's based on a bunch of research. Now, I actually kind of cheated a little bit when I described chat. So this is just the what you saw when I was talking about level 4 of AI tradecraft. Um, this is already agentic. So the ChatGPT that you use today, for example, it's already an agent-based system because it is able to take at least this action of launching a search. So that is the most reliable action that agent-based systems can take today is simple things like launching a search, using a tool like check the weather, obtain some data, very simple tool use. And those actions, can be injected into a chat format. However, this is the way you should think about agents today. So there's a ton of hype around agents, and this is the year of agents. So they are finding uses, and it's spreading fast, and they're developing fast, but it's pretty early days. So this is one way to think about self-driving cars, right? At level 0, you have absolutely no automation. The human has to turn every crank, pull every, you know, uh, turn every dial, pull every whatever. Level 1 is there might be a little bit of automation, like automatic braking. So it's just like one tiny task at a time is compartmentalized and automated. So you don't have to do that one thing. At level 2, you're starting to get lots of automation. The difference between level 1 and level 2 is pretty fuzzy. But I think conceptually, the idea is just like, okay, a lot of things are getting automated. And it gets really interesting when you get to level 3. So a level 3 self-driving car, you could, for example, ask it to parallel park. So you are a human driver completely in control until you need something done, like park this car. And you might be right next to the parking spot in question, and the car just does it. Or you might be on the highway and you say, okay, keep me driving at this speed in this lane. Don't crash. There's some kind of very big functionality that you can trust the car to do, but you have to have hand on the wheel, being ready to intervene. Level 4, so I'm talking to you from San Francisco right now, and right outside my window, there are weird little white cars with LiDAR scanners on top by a company named Waymo. And these Waymo cars are level 4. So these cars are completely driverless, but only in certain environments. So they're not being trusted on the open highway, interstate highways between cities yet. There's also a whole bunch of humans who are actually monitoring these cars remotely, and they intervene quite often when needed. And the dream is level 5, where the car can be just fully trusted, no driver, it just does its job. So the question is, where do you think AI systems are right now when it comes to the job of an intelligence analyst? I believe that we are solidly in level 3. So I think that there are certain very constrained tasks in very constrained environments where you can trust an AI agent-based system to just take care of things when it comes to intelligence analysts. For example, write me a research report. But I think that it's fairer to call it level 3. Really, the human analyst has her hand on the wheel. And so I think it's the better metaphor instead of self-driving cars is that you essentially currently at level 3, you have an AI intern. So we would love to have a junior analyst. I think you get to level 4 when you have a junior analyst that's fully AI. But I think we're still at level 3, honestly. And the tradecraft that you and the audience need to know about is everything I just described so far, especially level 1 through 4. But agents are coming fast. They're finding their way into applications. And so I want you to just be aware of what it means. There's nothing magical about it. It's really just giving RAG systems, so large language models hooked up to systems like search, the ability to make choices to take certain actions. And currently, we have to hard code what those optional actions are. So we human coders, we can decide in advance, what is the thing able to do? Launch a search or just say something in chat. That's the default. But increasingly, it's going to be open files, write things, open spreadsheets, put things into those spreadsheets, access a map, generate, change the map. There's going to be a ever-growing menu of options for actions that the system can take. And that's how we're going to grow into level 4. And I think it's happening this year. So I already see it happening. But where we are today, quite honestly, level 3. So there's very, very few AI systems out there that you can just trust, no hand on the wheel, to do something important. You can trust them to do things like, write a research report if if it isn't high stakes. You can trust it to answer questions and come up with maps. Again, all on its own, as long as it's not super high stakes. But when it comes to an intelligence analyst, everything is high stakes, right? Lives are on the line. It's national security. And so we are squarely in level 3 today. But I think by the end of this year, certainly next year, we're going to start getting into level 4. So I designed this talk to basically arm you for this coming year. I want you to understand what these 5 levels of the AI tradecraft are as of today. So number 1, you need to understand how search works, particularly semantic search. It has its limitations, which I'm happy to get into. It's not like a magic bullet. Structure. Any search system you're using will usually have some structure, and frankly, the more structure, the better that you can take advantage of. But you need to know it's there. You need to know how to use it. RAG, whenever you have a large language model in the mix, it's an incredible time saver. The main thing it's doing, and this is important to keep in mind, is it's just lowering the cost of using these systems. It's having that AI buddy looking over your shoulder and sharing its point of view, and hopefully it's useful. So, that's the main thing that RAG does. Oops. Chat is really just a much more natural interface for having the LLM help you. And finally, agents is just when you have chat plus actions. And the number of actions it can take is going to grow and grow. So with that, thank you very much.
All right. Thank you so much, John. We really appreciate you speaking with us today. And also thank you to everyone for being with us this afternoon. We really hope this webinar has been helpful for you and your organization. If you have any further questions or would like to request more information, please feel free to contact us via the information on the slide.